Okay, so as we look at parabolas at 8:25 at West Dallas Central, coming to you live from room 254 on the second floor.
Yeah.
We're taking a look at the standard equations of a parabola. The parabola is going to have three interesting features about it. We have the focus, the vertex, and the directrix. We've been dealing with the vertex of a parabola probably since about freshman year of high school. That was one of the things you always used to plot a parabola. But now we're going to actually be adding in a couple other features, the focus and the vertex. The equations down below here, the standard equations of a parabola, are used to find the directrix and the axis of symmetry, as well as the focus of the parabola. Now, something interesting that you'll notice is that we have x squared equals 4p times y. A lot of times we've always wanted to take and get y equals something and x. Okay? But now we're actually going to get the x part by itself and move all the other junk over with the y. We also have this other variation here where actually it's y squared equals 4p times x, and that is actually going to turn the parabola 90 degrees, and it's going to open up horizontally instead of vertically when that happens. All right, so let's go ahead and apply this stuff and see what happens. Example 1, identify the focus and the directrix of the parabola given by x equals 3/4 times y squared. And then we want to draw the parabola. So why don't you go ahead and copy that down. So as we look at our equation, x equals 3/4 y squared, the first thing we want to notice is that it's not set up like we had in the previous slide with the x squared or the y squared by itself. So I want to get the y squared term by itself. Right now y squared is being multiplied by 3/4. So to undo that, let's multiply each side by the reciprocal of that coefficient, 4/3. Now I have 4/3 x equals y squared. The next thing we want to notice is that all of those equations on the previous slide always had it as 4p times y, or 4p times x. So I want to rewrite this as 4 times something times x. That something will be our p-value. So this 4/3 I'm actually going to rewrite as 4 times 1/3 times x equals y squared. So now the p-value becomes apparent. P is equal to 1/3. And that p-value is going to unlock a lot of features about this graph. First thing is it's going to unlock the focus. Now since we have y squared, we're going to have a focus at p0. So let's go mark that on here, p0, so at 1/3 0 will be my focus. That's my focus. The next thing I can find from the p-value is my directrix, and that will be at x equals -p. So at x equals -1/3 will be my directrix. So I'm going to go ahead and draw that in there. X equals -1/3. That is my directrix. Going back here, I also get my axis of symmetry will happen at this y equals 0. Okay, so y equals 0 will be my axis of symmetry. I'll go ahead and put that in there. Y equals 0. And then it also says, when we have it in this format, the vertex is at 0, 0. So my vertex will be at 0, 0. That's my vertex, is at 0, 0. All right, so now I just need a couple more points. So I'm going to just make a real quick x, y table. And since y is being squared, it might be easier to choose some y values and get the corresponding x's from that. Okay, so let's choose like maybe y equals 2. And I'm going to plug that into my equation up here. So 2 squared is 4, times 3/4 gives me 3. Okay, so I'll have at the point 3, 2, I'll have, 3, 2. There we go. I'll have another point on my parabola. Also, if I put in negative 2 for y, negative 2 squared is 4, times 3/4 is 3. So I get the point 3, negative 2. 3, negative 2, also on my parabola. And then I can go ahead and sketch this in. It's got a couple points on there. I got my focus, I've got my directrix, I got my vertex, I got my axis of symmetry. All that stuff is on there. This could similarly happen if I had x squared instead of y squared, except then it would be opening up or down instead of to the right or to the left. Okay? That is an introduction to graphing parabola.